All right, good morning and happy Friday, my Leak Code problem solving friends. I'm planning on doing the Leak Code daily challenge for today, March 31st. Get some music going here and share my screen, and we'll start jamming. Right. Problems. 31st. Number of ways of cutting a pizza. Interesting. I do remember seeing this some time ago. So I think I solved this a while ago. And yeah, I solved this about 3 years ago. Anyhow, let me see, get some music going, and then we'll jam on this and read it a little bit more thoroughly. Okay, and it is 6:16 a.m. and it's time to shine. Okay, A is an apple, dot's an integer cell, K is an integer. We have to cut into K. Pieces using K minus one cuts. And choose vertical or horizontal cut position. Okay, give the left part to the pizza, or the upper part. And then the last person gets the last piece. Number of ways of counting things. So, okay, this is a huge hint, right? If we're counting things, we're probably going to use the rule of product, right? So, oops. Counting things mod 1e9 plus 7 is a huge hint, right? Huge hint that we will use combinatorics, which is just like a fancy way of saying counting stuff. And also use the past to formulate the future, which would be dynamic programming. Okay, so what do we got here? We got 3 apples, 3 ways to cut the pizza horizontally, vertically, there. All right, so here's the previous subproblem, which make this choice, and then we have these 2 choices after that first choice. Otherwise, we cut it vertically, and then we only have one additional choice. Okay. So whenever there's only one slice left is our base case, right? So base case occurs when we have one slice left. So it's 50 by 50, so it's pretty small. A slice is 10. Oh, there's a whole bunch of hints. Okay, we might have to go through those. Let's see. So, all right, let's do pizza as our matrix, and then K is our amount of slices. And let's try to do this top down first and then bottom up, and we'll see what happens. All right, so top down, we only care about slices with apples in it. So if there's no apple in the slice, we can basically ignore it. Right, so there's no slice down here because there's no apple down there. Okay, so how do we determine? I guess the first question is, right, how do we determine when to slice and when we cannot slice? Right, so we can slice when there exists an apple on each side. oops, each side, at least, right? At least, right, at least one apple on each side of the slice. Right, and it follows that we cannot slice when there does not exist at least one apple on each side of the slice. Right, so we can't slice it down here because there's no apples down there. So then coming back to the original question, I guess we'd want to pre-process the input, right? So we determine in one time if we can make a slice or not, right? To make this determination in one time, right? So offhand, I'm thinking two-dimensional prefix sums. I wonder if that's too complicated though. Right, 2D prefix sums help. And so what if we have this thing, right? For example one, we have a dot dot, a, and dot dot dot. So what would two-dimensional prefix sums look like? We can say ones and zeros, whether there's apples or not, right? Something like that. And the recurrence relation would be the top plus the left minus the top left, since that's counted twice. I wonder, I suppose this might be too complicated, right? This might be overkill though. We just want to know, right? Now if there exists an apple on a per row and column basis, right? So there's an apple on each row, but then we slice it this way, there might not be an apple on the row. So maybe we still need this. Okay. Yeah, so if there were no apples at the end here, this column would be no good, right? So this column's no good. And then similarly, this row is no good, right? This row is not a candidate for a slice, right? And make a big red X. Similarly, this column would also not be a candidate, oops, for a slice. And there are no apples in the column. Right, it follows also essentially there are no apples. Oops, apples in the row. Right, the rightmost column. Oops, most column. Like bottommost row. If there was an apple over here, then right, we could skip. We should still be able to make that slice, right? Yeah, so can't just check that one column. We have to check similarly, right? There could be another row down here with an apple, and then that'd be okay. Right, or an apple way over here. In which case, the slices are okay, I think, right? Yeah, so the pizza itself is both apples and non-apples. So yeah, maybe two-dimensional prefix sums makes sense then in that case. So what would two-dimensional prefix sum look like? Actually, the suffix sum is probably easier than the prefix sum. That way we don't have to offset the DP matrix by one. That is, if we put the base case as index 0, then the matrix of the DP for the base case would be offset from the matrix A, the input, by one. Whereas if we put the base case at M and N, where M is the cardinality of the rows and N is the cardinality of the columns, then we would not have to offset the DP matrix. And I think that would simplify the code. So that'll be the game plan, right? Instead of prefix sums, we write 2D prefix sums. We can construct 2D suffix sums, right? So the prefix sums recurrence relation is built from the top left, right? Right, so by starting from the top left and going to the bottom right, whereas the suffix sums, recurrence relation is built from starting, built by starting from the bottom right and going to the top left. Right. Base cases at 0, 0. Base cases at M and N correspondingly for the rows and columns. So anyhow, if we're gonna use this guy as our input, then the corresponding prefix sums would be built on it from the bottom up. So the base case will be zeros. All right, here's our base case for the columns would be here. And the base case for the rows would be here. So this would end up being 2, 3, 1, 2, 4. And then we can calculate the relative apples based on the absolutes. Right, so 2D suffix sum recurrence relation would be right for each ij cell, right? dp sub I sub j equals dp sub I plus 1, the row below, plus dp sub I sub j plus 1, the column to the right, or the cell to the right, right? And minus the one down and to the right, since that's counted twice, right? Counted twice, you subtract it once. I think that makes sense. Right, so if I wanted to say, hey, are there apples? Right, if I was going to answer, right, to answer the question, is there an apple at, I guess, below or to the right of cell ij? I mean, can we split the pizza at ij j vertically or horizontally. I guess horizontally or vertically. This is what we want to ask ourselves. And to answer that question, right, we should be able to look at the current cell and then the cell to the right, as well as the current cell and the cell below. And so is there an apple to the right or below this guy? And then is there an apple to the right or below this guy? So in this case, the answer would be no, there's no apple below because this guy's 0. And we can say yes because the apple would be to the right. And I think that makes sense. Yeah, we don't actually need to find out how many apples there are. Well, we could find the relative offsets from the absolute offsets, right? So the absolute offsets, or absolute sums is the DP matrix itself. Relative sums of quadrants can be derived in O of one time. And basically, we can take we have something like this, right? So, oops. This chunk could be anywhere. We'd want to take prefix sum or the suffix sum here for this cell. Actually, how would I want to explain this? It's easier to draw it on a piece of paper than to write the ASCII. And basically, you want to kind of do this somewhat in reverse, in that the recurrence relation builds upon itself and it subtracts. We'd want to take the absolutes to create the relatives. Anyhow, I don't know if I don't think I need to go into that and explain it. So I think just looking if it's non-zero would be sufficient. Yes, there is an apple, like for this cell, 0, 1. Yes, there's an apple to the right, and there's an apple down below because the DP matrix is non-zero. Anyhow, what I was going to explain, though, is the 2D prefix sums. Let's see. Pretty sure, yeah, this is a good example. What I mean by the, oops, hold on, let's see. Constructing the, oh, I thought there's a picture. Oh yeah, okay, I did put a picture. Yeah, so constructing the DP matrix in a way where we can basically calculate this relative two-dimensional sum based on the absolute sums. So the absolute sums are from the origin, from the top right. That is, we would take this diagonal portion, which is counted twice, and we'll add it back once because we subtract it once here for above. We subtract this once here for left. So then we add it back once here, basically the opposite of the recurrence relation, in order to calculate the relative offset of the green section based on the absolute offset of the origin from the top left. Right, so that's what I mean. So if you're all wondering what I mean by that, you can look at this guy. This is kind of the basics from which a handful of other LeetCode problems are derived. Range some of the 2D query immutable. Okay, so anyhow, Before I digress on that tangent, let's get back to here. I think that's overkill. We don't really need to go into that to find out how many apples there are. We just need to know if there is an apple or not, for which zero and non-zero value seems sufficient. Right, so when the cell to the left, right, the DP cell to the left, DP cell to the left of IJ, that would be IJ plus 1 is non-zero. We can slice, right? And then similarly, when the DP cell below IJ, that would be I plus 1 J, is non-zero. We can slice. Okay, so we have those two that can be determined based on DP matrix. So let's write that code real quick. So this is M is the cardinality of the rows, and then N is the cardinality of the columns of the matrix A. And then our DP matrix be basically we'll create a copy of A and then append it. Yeah, so let's do this. Let's just make it zeros for now, and it'll be N plus 1 columns for N plus 1 rows. So Python 3 is kind of strange in that we read it from right to left sometimes, left to right sometimes. In this case, we read it from right to left. So this will be the rows, and for each row, we create that many columns. And we add one for the base cases, which would be the rightmost column and bottommost row, which we iteratively and optimally will build upon basically the 2D prefix sums or suffix sums. So for IN, the reversed range M, right, for each row from M minus 1 down to 0 inclusive, and then for J in reversed range N, that is from N minus 1 down to 0 inclusive, we'll construct the DP matrix based on the recurrence relation defined up above, right? So the row below plus the column to the right minus the diagonal below and to the right, so that's counted twice. And then let's here for row and DP, we'll just print it out row. And then we also, I forgot, we need to add on A sub I sub J, right? So that value will be 1 if that is equal to the character A. There's an apple there, otherwise it's 0. Okay, and then let's return -1 for now and run this. It should be this guy. Obviously, yeah, so it looks good. Now we can determine in O of 1 time if we can make a slice horizontally or vertically for each IJ cell. Right, so then it's one way to slice it there, and then of that one way, how many ways can we slice it vertically? And horizontally, right? We want to multiply it. So using the rule of product from combinatorics, we're just a fancy way of counting things. We use the rule of product. Right, for one slice, we can count multiple slices, multiply it by themselves, modulus 29 plus 7. Okay, so this has taken a while to kind of think through, but this is not necessarily straightforward or trivial. What did it take? 23 minutes. 23 minutes for game plan plus pre-processing of the input. Okay, and then at 6:39 a.m., which is right now, we'll start on the core implementation. down, right? And then get a memo based on that. Okay. So see def go. It doesn't really matter where we start, as long as we visit each cell. Okay, if there's an apple at that cell, or at the ith row, jth column, then we can slice it vertically and horizontally, otherwise we cannot. Okay, so let's do this. If count is what will return go as a recursive stack unwinds, it'll accumulate via the rule of product the answer. All right, so we got either horizontal or vertical. We'll call it down and to the right, DNR. All right, so horizontal slice will be down. Vertical slice will be right, the count, right? Counts from. Okay, so down will equal is there an apple to the right, right? So whatever, if dp sub I sub I plus 1 sub j, if that's otherwise 0, let's see, count would be if there's an apple there. There's an apple here. Well, we're counting slices, not apples. So try not to get confused or hung up on the nitty-gritty details, right? Be whatever if dp sub I sub j plus 1. And what will it be then? Right, we have to recursively go and find out all the ones after we make that slice down. And then we'll accumulate them as the recursive stack unwinds. And so there's this handful of subproblems. So we'll end up going down. Here we'll end up going to the right. And then don't want to forget the modding by this guy. The count is one way and then times the other ways. Down and to the right. Where's the base case going to be? And how do we set that and start building on it? If we make our first horizontal slice here, then that counts as 1. And of that 1, we can have 1, 2. So 1 multiplied by 2 1 plus, right, 1 slice plus that, or I want it. Wonder if we need count then. So the base case will be if I is equal to m or j is equal to n, right? Then we'll just return 0. There's no way to slice it in that case, right? Then as a recursive stack of lines, we accumulate to multiply, then the 1 plus should save us from those bottom up zeros, right? We don't want to multiply by 0. Down times the right. Oops. So I don't know if we need count or not. Something like this, right? So here's our DP matrix, right, which we came up with basically up here. Turn it out a little bit nicer. Well, let's walk through this code. Oops. Make sure it makes sense. Okay, so go 0, 0. Down equals 1 plus go 1, 0. All right, so basically at this cell plus, oops, right is n plus go 0, 1. Consider down first. So if at cell 0 or 1, 0, cannot slice further down. So down from this relative position will be 0, right? Since the DP matrix says there's no apple down there, right? We can do. Okay, so right equals 1 plus go 1, 1. So be at this cell. You can slice it that way, which would be, you said this slice. Right, so we made that first horizontal slice, make this slice. Okay, from this perspective, right, down 1, 1, down would also be 0, right? We can't make any vertical or horizontal slices. We can make another one to the right though. 1 plus go 1, 2. It's this cell, which should be this apple here, mimicking that slice there. Okay, and then if we're at cell 1, 2, this guy, we can't make any cut to the right or to the left, right? So this is where the recursive stack bottoms out and begins to unwind. Okay, which leads us back up to where we were. So this guy, as a recursive stack unwinds, will accumulate down and to the right. That doesn't look right. Down plus to the right then. The amount of ways down, the amount of ways right. Right, so it'd be 1 plus 1. This guy would end up being 2 as a recursive stack unwinds, right? This is 0 plus, or 1 plus 0 equals 1. Doesn't look quite right. Or no, this is right. Yeah, we can slice to the right. Doesn't look quite right though. So that'd end up being 2 is 1 plus 1 equals 2. And then this is counting too much. 1 plus 2 to equal 3, which is that too many? I think so. Yeah, right. There's one slice here. That one slice. There's 2. So when do we want to add one way of making the slice? One plus down and to the right? Right, this should be two. Right before we get to the right slice here, which would be this guy. Should end up being one. Make this first horizontal slice, and of that horizontal slice, we want to take the multiple. How many are there? And we only want to make each slice once, right? When we go through this thing, we want to count that horizontal slice more than once. Okay, so that should be okay. So I need to reconsider how I'm accumulating the slices here. One, two. So if there is no apple at that cell, then I suppose we don't want to consider it then, right? If not dp sub I, or not, so if not a sub I equals a, like there's no apple there, then yeah, we'll just count it as zero, right? Hold on, oops. If that and this, right? So there's an apple there at that cell, and then there's an apple somewhere to the right and somewhere down below. Then we can make the horizontal and vertical cuts down and to the right correspondingly. Okay, and then as a recursive stack on one, so we want this to be two. All right, the goal is for this to be two. This accumulated sum to be two. So it should be like 2 times 1. Let's do this. 1 plus down times the right. Would that work out? So if down times the right would be 0. So 1 plus that. And then here it'd be 1 plus down times the right. Which would be 1 again. Down. There's the right. No, that's not quite right, right? Because this one slice, there's 2 vertical slices. Down times the right, accumulated 1. Okay, so here would be 0, 0. Go at 1, 2, right? You can't slice anywhere. So here would be 1, 2, row 1, column 2. We cannot cut down or to the right at 1, 2. So it'd be 0, 0, 0. Actually, 1 plus, right? Right would be 1 plus 0. Okay, so 1. Okay, and this guy down times the right. Doesn't seem quite right though. Down times the right would negate these ones. Down times the right. Yeah. Well, this guy should return 1. Right, because there is an apple there. 0, 1, 1, 2, 0, 1, 2. This should count as one way. Hmm. I think I'm close, but this is a little tricky. Right, how do we accumulate this in? We do 1 horizontal slice. Right here would be 2. 1 and 1. Down is okay. And so problem with down would be 1, 2. wonder, let's see. Still want to recursively go regardless if there's an apple or not, though, right? We can do this. Oops. So if we have an apple, we'll count it as one, and then we'll multiply it by the amount that are down and to the right. Does that work? One plus down to the right is one. Down times the right. One plus down times the right. That'd be one as well. Plus down times the right would also be one. This guy returns one to the right. Is there any way to slice this one though? Right here, there's no way to slice down or to the right. Here, there's one way to slice to the right. Doesn't seem quite right. I think it's a little bit off, right? Let's just run this thing. It's over counting, right? And it's not even like this would be over counting, isn't it? Under counting in that case. I wonder if I could do this. Kind of throwing things up on the wall to see what sticks now, though. It's kind of like an educated guess, like kind of playing around with the input. Seems, let's see, 639, 705. I'm kind of spinning my wheels now. What is this? About 16 minutes. Is it? Yeah, about 16 minutes for implementation, which is almost there, right? Almost. We're getting there, I think. Right, we're getting close. Right, we have to just find out how we can get the accumulated sum of two. Right, there's two ways of slicing it this way, down and to the right. So as the recursive stack unwinds, how to get to two for that, and then one vertically, one and one. Right, right. Not enough. I have sold this before 3 years ago. But I wonder, did I cheat and look at another solution, or did I come up with it legitimately? I don't know. Like I tried a couple things and finally got it. Oh, you have to cut it into K pieces using K minus one cuts. I'm not even using K. So we're constraining it by K cuts. Ah, only have K cuts though, using three cuts. One, two, three. K minus one cuts. Okay. So in K equals K equals one, then that's the base case. All right. So okay. If K equals one, then return one. K initially equals K. Right, note, I totally forgot all about K. Oops. There's a lot going on, right? So it happens, whatever. I'm not perfect. Okay. So in that case, this might be. Right, if you make a cut here, it K minus one cuts remaining. Same for here. Slice there. Make a slice there. We got no cuts remaining. So that counts as one. Make a slice there. Make a slice there. That counts as another one. Let's see. Not not quite. Okay, so accumulate down to the right. Let's see. One here and one there. It's three. That's not right. It's saying I can do two. All right, so I do want this, right? So if there's an apple there, no, it doesn't count enough in that case. Is there an apple here? Might be the base case, right? I think that might make more sense. Right? If there's an apple there at the remaining one cell or the slice, then count it. No, that's not quite right. Okay, so actually from this guy, we already know there has to be an apple somewhere over there. It might not be on that cell exactly, but this counts too many, right? For this guy counts two, whereas it should be one. Zero, zero, one, one, zero, 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 zero. It should just be one instead of two. Why is that? I have to make two cuts. Should return one. One way to go down. I think we do want to multiply, right? We want to use rule of product. And these things zero out. Way, only one way to cut this thing, right? Cut it horizontally first. Then you can't vertically first. One, right? Cut that chunk, and then you can cut that chunk. One way to do it was we cut this chunk and then cut that chunk. It seems like there's two, isn't there? I thought this would be two. Maybe this is what I'm coming up with is two. One way that way, one way this way, one way this way, then one way that way. It's still the same way. It's the same cut that's being made then in two different ways. Same cut is being made in two different ways. I want to count each IJ cell only once. Scene is a set. And one if IJ IJ not in scene was zero. Add. Okay, so when the recursive stack bottoms out at a certain point, we only count that once. Does that sound right? We don't want to adversely affect the other ones though, right? So that adversely affects this guy. If we want to look at the hints or not. Need to. Or if after we process it, do we want to set the apple to nothing? That we don't process it then once? I don't know. I feel like I'm pretty close there. me just slice it in this case. It's being guarded by this as a safe move. There has to be at least one apple to make that cut. This is over counting though. It counts too much, right? It says there's two ways of doing this, and there are two ways of doing it, right? But they're not two unique ways of doing it. It horizontally. Right, the horizontal cut would be 100 on top, and then we'd have below would be 110. One way to slice it, or let me see if I can draw a picture. Hit it horizontally first, be like this. Cut it vertically second, be like that. If I cut it vertically first, it'd be like this. One way of doing it. Then there's zero ways of slicing this right hand part there, right? Other than that, one slice that way. Okay, I wouldn't do that right one, right? That wouldn't work. There's no apple. Wait, this apple does count to the right. But it's the horizontal row low. Yeah. I'm gonna keep track of that separately. So one single DP matrix is a two-dimensional prefix sum. We have a per row and per column basis. Oh, yeah, I want to consider that one to the right as a slice. Yeah, I think that makes sense. And my kids are about to go to the bus stop. I'm wondering if I should stop here. It seems like I could use a break. Here, 2D suffix sums results in too many. All right, for this use case, we don't want to cut to the right here. Let's do this for row and column then. We want to keep track of how many are to the right and how many are down. Each row or each position. Here, and let's just look at the ends, make sure we're on the right track, right? think I'm on the right track, right? So it is DP. All right, and then we have to check if there's one to the right or down. All right, well, I've been struggling with this one for a while, so it's been a little bit over an hour. Hmm. Sometimes you see it, sometimes you don't, I suppose. I feel like I'm kind of in the right track, but then kind of just throwing stuff up on the wall to see what sticks as well. Suppose we can calculate down into the right. To know that that's 0. We don't want to make that cut to the right because it counts as 2 instead of 1. So the corresponding DP matrix for this guy would be 2, 1, 0, 2, 1, 0, 0, 0, 0. So in order to know that there's minus that plus that minus that. Hold on. There's 2 plus that. To know if there's 1 there or not. Hold on, maybe I can keep this. This minus that plus that. Is there an apple on this slice? Multiply those by 0. There's just an apple there. Oh, and you make the cut. Yes, but then it also depends on this guy. That makes sense. No, not quite right. So is there an existing apple here? Mm-hmm. Yeah, I'm just throwing stuff on the wall, see what sticks. I'm pretty sure I'm close, but not quite right, right? which doesn't really count officially. Okay, usually I take a break and then work on this later on after I have my subconscious work on it. But in the sake of recording, might as well maybe just look at the previous answer I came up with. That is cheating though, for sure, right? So the gist of it though is I want to make a horizontal slice here, but not a vertical slice. Otherwise it counts as two. So how do I make a horizontal slice without a vertical slice, right? Okay, so I I'm gonna keep it super simple, right? Don't confuse myself. It's not down plus the right? We should be using the rule of product. It's not quite right. Oops. If there is an apple to the right or down to the left, and then if you can make that slice, right? So there's too many constraints here. So overly constraining the first one, underly constraining the other ones. Pretty close. I can feel it. But yeah, feelings might not be quite so accurate, right? So okay, let's look at what I came up with previously, and we'll come back to this one again because there's obviously room for improvement, right? Upper piece contains at least one apple. Left piece contains at least one apple. The piece of IJ. Hmm. Okay, so there's my two-dimensional prefix sum. So it's on the right track for that. Okay. There's no apple. Return 0. There's no cuts. So return 1, right? Keep me at the counts. Down and to the left. I plus k is less than or equal to m. I see the k cuts are from 1 to m inclusive and 1 to n inclusive. Okay, yeah, that's tricky. 1 to n inclusive, 1 to m inclusive. This thing target T and the K cuts. Yeah, that sounds good. All right. Here's our target T. T is T. If not T, return 1. If not dp sub I sub j, return 0. And there's no apple there. Otherwise, here's our goal. And then we don't need to consider that because we're not going to go any further than the K cuts. For the rows, I'm turn the count to the end here. Or actually, I just do down and to the right is okay, right? Down to the right, turn, down plus right, and then don't forget the mod, right? Those are the K cuts. Actually, is it 1 to M? Or from I to M? It should be I to M, right? And J to N, isn't it? We don't have to go back. Right, I should just keep going forward. I think. We'll see what happens. Okay, so right, the DP matrix, this guy minus the cut at that guy. A K is M minus I, isn't it? I'm confusing myself now. I plus K should be less than or equal to M, yeah. It's a little bit weird to write this in Python, but right, you want it to not surpass M. And if that exceeds 0, then down equals go I plus kj t minus 1, right? Like that. Oops, I, j, I, j plus k, right equals go, I plus 1, oops, I, j plus 1, t minus 1, turn down plus the right. Turn 0 for this case. Oops, j plus k. Oops, j minus j. So don't, oh, we're past the bounds and we're still under counting. J plus k. Yeah, I'm kind of spent. So yeah, let's just look at this. Kind of a bummer. I didn't really get this, but I'm a work in progress. I don't need to be perfect. I have significant room for improvement in DP, even though I've been studying it for a while. Yeah, well, the obstacle is the way. This is just so close. And it's strange that I'm having such a hard time. But that's how DP is. It's pretty tricky. Right, so what am I doing here? plus this minus that, right? That makes sense. It's a recurrence relation. I'm building that fine. 1 to m inclusive. Oh, to m inclusive. Is that what I'm missing? No. That's strange. This isn't working. I'm like looking at the solution. It's like, why is this not working? I don't know. Here, k equals 1. Or is it? Well, I plus k is less than or equal to m. I keep doing this, and then I plus equals 1. K equals 1 again, and while j plus k is less than, oops, j plus k is less than or equal to n. I do this, j plus equals 1. Is there something wrong with my for loops in Python as I translate it from here to there? That's not quite right at all. Oh, oops, I'm missing this, right? I plus k, j plus k. That's not right at all. It's not what we want to increment. We want to increment k for each iteration of the loop. Okay, I think that's what I was missing. Plus 1. Well, this is when you know it's kind of, I'm pretty confused. It's like I'm looking at the solution, I still kind of don't get it. Why am I missing here? Why is this thing not working? Equals 1 equals 1. Down and to the right. Oh, yeah, k equals I, isn't it? No. I do want k to equal 1. Okay, k is the offset. That's just weird. This looks exactly the same to me. I'm not doing the mod because I think that's a little bit more complicated. But man, I'm still having a hard time even when I'm staring at this solution. Okay, I gotta add a memo for it to be accepted. It's fine. But this is the basic thing. Hmm. There's one cut left. That's what I'm missing then. All right, so it's offset by 1. T equals 1, return 1. Ah, down plus equals. Okay. Right plus equals. That's what I was missing. Okay. A couple of little things can quickly throw us off. All right, so it should be able to memorize it. Each of the K cuts, and yeah, this makes more logical sense. Right, yeah, we can make these cuts. Oh, okay. In addition to the memo, I do need to mod it. by 1e9 plus 7. Right, and then right would also be right plus this guy. Just mod. That should be accepted. All right, okay, cool. So I had to cheat a little bit, unfortunately, and I have a feeling like I kind of cheated the first time I went through that too. Or I looked at someone else's solution. So, and that's how you have to learn sometimes, right? It's not right, that straightforward. But I was kind of on the right track though, right? In that we can make the cake cuts, but I didn't iterate through each of the possibilities in a logical way that makes sense. I started just kind of like throwing stuff up on the wall to see what would stick. I wonder if we need this. Turn 0 in that case. Yeah, we do. Otherwise, we overcount, right? There's one slice left, but there's no apple. We don't want to count it down and to the right. Okay, so anyhow, we can clean this up right for k in range 1 to n minus I. Be sure this would be the same. Yeah. Or in range, oops, range 1 to n minus I or n minus j. Same thing. And for readability, we can make these things line up. And yeah, this would make a linter line up, light up like it's Christmas or Diwali or whatever kind of light festival holiday. But in the case of algorithms and data structures and LeetCode, it seems to make sense to have these things line up so you can see, oh, okay, here's what's going on. Nice, that's what I think. Oops, it's a let's do this. Equal yourself. Oops. Down to the right. Yeah, algorithms and data structures are hard enough without having the code that aligns where you can see, oh, okay, we're going from k to 1 to how many k's will fit. Offsetting I by k rows and offsetting j by k columns. If we have an apple for that kth slice. So this is a decent solution. And yeah, we should be able to do this bottom up as well. And yeah, I'll probably try this bottom up here in a bit, but I don't know if I want to do that right now. So I'm pretty worn out. So as the recursive stack unwinds, we go from n minus 1 down to 0. Return 0, 0 t eventually. Well, I cheated on the top down. Might as well try to do bottom up legit, right? So when I previously solved this, let's go back here. I did top down, right? I think. Or did I do bottom up too? No, I did not do bottom up. Okay, we can try doing bottom up. I don't know how long has it been? Man, it's been like an hour and 30 minutes. It's a total bummer. I would cheat on this a little bit to kind of get going, but sometimes that's the only way to make progress. Uh, It's a decent solution. Okay, let's try to do it bottom up. 7:47 a.m. for bottom up. For I in reverse range M, and then for J in reverse range N, for T in reverse range So from 2 onwards, you can build upon the base case of 1s. 2 to T inclusive. That's our DP matrix for the prefix sums. And then we don't want to confuse that with what our memoized solutions will be. So our memo, which is top down this guy, will explicitly be 0 times T plus 1 for each column for each row. And then we want to explicitly set the base cases to 1 when T is 1, M sub I sub J sub 1 equals 1 will be the base case for when T equals 1 for I in range M. For T, oops, that's good enough, right? 0 to M and 0 to N inclusive. These are our base cases. And then we'll want to take this guy, basically set H, oops, dp sub I sub J sub T cell equal to that guy. This will be our explicit memo, dp sub I sub K sub J, T minus 1. Similarly for this guy, dp sub I, K, so this is basically our explicit iteratively building upon the bottom up solutions, then eventually return 0, oops, dp sub 0, sub 0, sub T, which are our original problem. Okay, something like that would be bottom up, I believe. Oh, and Tom Jacques support item assignment. It's not quite right. Oh, it's M. M is our memo, right? Don't want to confuse our memo with our prefix sums. Yes, it's our memo. And this is our prefix sums. And this one's tricky. It's tricky for sure. There's a lot going on, right? And that is not right. 6, 5, 1. I think we want to make our slices counting too much, right? I don't know if this matters or not, but definitely this is the boundaries of my knowledge of dynamic programming, right? So obviously struggling here. Uh, so as the recursive stack unwinds, we'll hit the base case of, oh, if not, oh, okay. So actually, hold on, I think I was close then. So if, I forgot this case, if not dp sub I sub j, then we'll return 0 in that case. But so we only want to go into this guy if that is true. So actually, let's do this. So just continue because it's 0, right? Oh man, still counting too much. Make our key slices consideration ij cell. It's now I'm just kind of throwing things on the wall again to see what stick. Not quite right. Because at the very end, when the versus stack bottoms out, T. Wait a sec. Hold on. T is 1. Yeah, that looks right. Dang, yeah, I'm just like spent. It can be a bit frustrating, but most of the growth occurs when we're struggling, and I don't think many people will record their struggles, right? And nothing really uh, entertaining, I think, or exciting about recording, struggling, and learning. It's much cooler to just kind of spit out what I already know. But it's definitely humbling to know, okay, I'm really struggling here. I have a lot of room for improvement. Yeah, this is kind of frustrating. Right? I mean, obviously, I've been in need of a break. Over counting. Then this is over counting. 0, 0 t is what will return to the end, and that'll mimic the recursive stack unwound the entire way. This calculation is the same. Just using our DP memo for the implicit memo. The memo I states IJT. Hij cell when t is 1, the base case is 1. That occurs when the recursive stack bottoms out. Why is it over counting? Like, why am I able to do this way iteratively that I did recursively? Counting them too many times. Set. Should be able to do this bottom up. I'm just not seeing it. It is worth mentioning though too, if the mind's distracted by other things, like some kind of nonsense going on in other parts of the life, it can definitely adversely affect the logical left side of the brain as well as the right side of the brain functioning optimally. I'm not seeing why we're over counting here. I don't know. Just thinking like maybe it's something simple like I have these loops wrong, right, in the wrong order. Then I get 0 for this one, so it's not building upon itself properly. This works. This is fine, top down. Bottom up in reverse should be iteratively doing what this thing is doing as the recursive stack unwinds. HA when t is 1. Okay. Okay. If there's no apple. It's just weird. Must be missing something though. And here's my base case, right? Which would be this guy. J. J1. This one's one. One down to I wonder. Does that need to be reversed as well? I think so, but we want to build upon ourselves. Oh, yeah. By the way, if anyone has any suggestions for improving, I'm definitely all ears. Significant room for improvement. Right, so this guy's not going to build up anything in here. Sort of reversing it. Yeah, that doesn't make sense, right? And if you want to return this to the end, you got to go the other direction to build on it. Otherwise, if we're going forward direction, we'd want to return this guy, right? What direction, return that guy. Okay. Well, to be continued, and that's like plenty for today. I'm exhausted. What is this? 18 minutes for incorrect solution. It is one of those Q4s, so definitely if you look at my Elite Code contest rating, I don't get the Q4, so still work in progress. Q4 is work in progress. I haven't consistently solved yet. Yeah, not out until you give up, right? So yeah, I'll come back to this. It's definitely an interesting problem I have to work on. No significant room for improvement. So definitely not perfect. And I am trying to improve it at least. So it could be worse, right? If I was not willing and able to change, I think I'd be in a whole lot more trouble than if I allow myself to be vulnerable, record myself, and make a complete idiot on myself sometimes, like now. Like, man, if I did the top down, you'd think I'd be able to do the bottom up, but it's just not turning out how I'd expect it to. It's really frustrating. Hey, this is the recursive stack unwinding. It goes in the reverse direction, like explicitly. And then this guy is also recursive stack unwinds. Go this way. It's just so strange that I'm over counting. I can't clearly see why though. As the recursive stack unwinds is 00t is our initial state. Just so weird. 6, 5, and why is it coming up with 6? All right, well, there it is, right? I have significant room for improvement for my observational skill set, so to be continued. My return on investment continuing right now is dwindling, so it's good to take some breaks. All right, well, catch you all next time.